So in the last lesson, we talked about just representing data sets. So kind of when you would use a histogram or a dot plot and when you would want a box plot and what those representations mean depending on what the graph looks like. So now what we're going to do is we're going to use information and we're going to just talk about how we would interpret a given data set. So we're going to use the example from page 217 in our workbooks. And this example gives us just the number of the student. So, we have student number 1, student number 2, student number 3, and it puts them in that order. What I have already done is I actually organized this data from least to greatest. So we've got whichever student, so student number 7, which is, just a way to label, to differentiate each student from each other, has a pencil that is 10.2 centimeters long. So that's a lot smaller than the next closest data point, which is 14, and so forth. So we've got it in order, which is going to make finding our statistics a little bit easier. So what we're going to look at here is we are going to calculate the interquartile range, because that's what number 2 was. But when we do that, we can actually find this other information pretty easily as well. So what I'm going to do is enter all of this data into my calculator, which I actually did before. And then we're going to follow those steps that we learned in the last video that I'll put in front of us in order to find the other statistics. So we've got, here are our steps. Oops. And so I have my data entered, which were these 3 steps, which we're used to. Then I'm going to press Stat, scroll over to Calc, and enter on one variable statistics. This gives me my mean and all of our other information. We can record this right here. I'm going to use a light blue. My mean is 16.03. My standard deviation is 1.8. My minimum is 10.2, which we already knew since we organized the data from least to greatest. My first quartile is 15.6, so that means that 25% of the data, the smallest 25%, is in the range from 10.2 to 15.6. My median is 16.1. My third quartile is 17, and my maximum is 19. What we were not given here was the interquartile range, which can easily be found by just doing our third quartile. Oh, that's what this should say, sorry. Minus our first quartile. So my third quartile is 17 minus my first quartile, which is 15.6. I can put that on the calculator if I want to. 17 minus 15.6, 1.4. So my middle 50% of my data only varies by 1.4 centimeters. So it's a pretty small interquartile range. So we've got a lot of values close together in the middle. And then the mean absolute deviation was actually not calculated for us. So if I need to figure out what that is, I can go to Stat. So I want both these things on here. Stat, I go over to Calc. I'm gonna click Enter. Then I'm going to click Enter again. Then I'm going to click Second Stat. And it'll display this menu. I want to arrow over to where it says Math, and I'm going to click Sum. And then I'm going to click math again. And I want to go over to number. And this time I want it to be the absolute value. So those are my absolute value bars. And then I want to click second one so that L1 is in that summation. Then I want to click minus and then vars. Notice how I'm just saying what is highlighted. And 5. And then I can click X bar, which is our mean. Remember when we have that little line above it? So 2. And then I can press 0 to close my parentheses. I'm just going to arrow over and close my parentheses. Divided by, I'm going to click vars again. And I'm going to click statistics. And I am going to select N because that's my total number of data values. All I have done is created that equation that we wrote on that very first note set. And I'm going to click enter. So my mean absolute deviation for this data set is 1.207. So it's a little bit different than the rest. So it's close to the standard deviation, but not quite the same, right? So that's my mean absolute deviation. What I need to do to determine if there are any outliers. So all we've done is calculated things we've talked about before. We haven't necessarily talked about outliers. There is a way to just look at a graph and pick out something that's kind of lying on the outside of the trend and you say, that's an outlier, but there's also a way to calculate outliers mathematically. So what I would do for that is I would multiply the inner quartile range by 1.5. So I'll do my inner quartile range, which is 1.4 times 1.5, and that gives me 2.1. So, yep, okay. And then in order to determine if there are any outliers at the lower end, I'm going to do my first quartile minus this number we just calculated. So my first quartile is 15.6. And I'm going to subtract that by this number we calculated here. So our inner quartile range times 1.5. And I'm going to get 13.5. So any data point that is lower than this number is considered an outlier. So looking back at our data, I can see pretty easily, since it's ordered from least to greatest, that 10.2 is an outlier because anything less than 13.5 is mathematically an outlier. And then to determine if I have an outlier on the, greater end, we are going to do the third quartile plus this number we came up with. So my third quartile is 17. And I'm going to do plus 2.1 this time, which gives me 19.1. I don't have any outliers on that upper end because I don't have anything greater than 19.1. My greatest value is 19. So which measure of center is better for the given data set? Essentially, if you have an outlier on one end, then you're going to want to use the median. Otherwise, your mean is skewed by that outlier. So for this example, our median is better because our mean is skewed by that lower end outlier. So our mean, and that makes sense because our mean is lower than our median by almost 0.1. So now that we have a little bit more information about the numbers that describes our data set with our pencil lengths, we can also represent these values graphically. So like we learned in the last video, we have our box plots and we have our histograms and we have our dot plots. Because there's a lot of data and it falls on a continuum and continuous like range, because we've got all these in between values, a histogram is better than a dot plot. So if I am looking at my histogram first, which is over here, we are going to want to think about how the data is grouped. So we've got our first bin, which is from 0 to 10, another from 10 to 11, 11 to 12, 12 to 13, 13 to 14, and so forth. So my first bin is going to not have anything. Then we've got this 10 by itself. And then from 14 to 15, we've got 2. From 15 to 16, where we're not including that 16, we have 1, 2, 3, 4, 5. From 16 to 17, we have our most. So we've got 1, 2, 3, 4, 5, 7. From 17 to 18, we've got 3. And then from 18 to 19, not including the 19, we have 1 and then 1. So on my histogram, I'm going to go and draw these boxes. So I've got from 10 to 11, we said we had 1. Our next rectangle doesn't start until 14 to 15, in which case we have 2. Then we've got 5 from 15 to 16. And we have 7 from 16 to 17. We have 3 from 17 to 18. We have 1 from 18 to 19 and 1 from 19 to 20. So this, we can tell pretty easily that it is going to be skewed to the left. So my mean is smaller than my median, which we already predicted because this value was an outlier. If we're doing a box plot, we have a few numbers that are important. So I'm going to fold this so we can actually look at those numbers while we create our box plot. So our magic numbers for it, I'm going to switch to green, are our minimum, which is 10.2. So I can't get super exact, but we'll say that's about where 10.2 is. But that is an outlier, so that can also just be a minimum as a dot, and then your whisker can start at the next smallest value. So if we did it like that, our whisker would start at 14. This is just a way to show an outlier. So this is my outlier. It is my minimum. Then we also know we have our first quartile, which is the beginning of our box at 15.6. So it's a little over the halfway. Then we've got our median, which is 16.1. And we've got our third quartile, which is 17. And we've got our maximum, which is 19. So besides that outlier, everything falls pretty close together. So this is a really good way to demonstrate, okay, this is my box plot and my whisker could be all the way to down here, but I can also just represent that with a dot showing the outlier. So if I'm going to describe the shape, center, and spread in the context of the problem, I can say most of my pencils are around 16 centimeters, except for we had our outlier, which was our just really short pencil that was around 10 centimeters. Otherwise, they're all around the same height. The spread, we said it was skewed to the left. So we've got, we can explain these graphs pretty easily.